Hello, welcome back. So today I'm going to be showing you how to create a server and also a client in Java. First of all, we are going to create a TCP server that echoes back the message sent from the client as the image shows, and it's going to be done in like 5 steps. All the steps will be shown accordingly. The first step will be to create a server socket object. Then the second one will be to put the server into waiting state, the one that is going to be waiting for a connection from the TCP client. And then we shall set up an input and output streams, send and also receive data. Then finally we shall close the connection. Okay, so I'll go here. I already set up my document and workspace, so we shall import the necessary packages. But before actually we import any packages, since you can already see here that you can see I already have like a folder open called network prog, where I put most of my networking programs. So I'll first say that this package is in the network prog folder. Then I import the packages. The IO pack, the one for IO, the input output, handles the input output streams, also the exception or the compile time error, the IO exception. Then we are also going to import the package for handling user input, especially from the client. So we are going to initiate the string variable we are going to use to handle the messages from the client side. That is going to store the messages from the client side to be echoed. Then we shall also need a variable, an integer basically, to take count of the messages sent and received, the messages received, and we are going to set this to 0 for now. We shall also need a server socket object. But we shall initiate this later. We shall also need a socket object, which is going to handle the links, and we shall call it link. We can set this to null for now. What's missing? I think that's so for now. Okay, so we go. First step we're going to do, we shall inform our user that we are trying to open the server, or we are opening the port, Then we are going to try. The reason we are going to use try, because whenever we are trying to set like a socket object to a server socket object, it's usually whenever we are trying to create a server socket object, it usually brings up a compile time error, an IO exception, and we need to handle it. So we shall put this in a try clause, and we shall say the server socket object. Oh, so I had forgotten, the variable. We need to initiate a variable that is going to handle our port. But sometimes you can just put the port there, but it's usually very good for you to have a port variable. So You can put any port you want from 1020 something there to 600 or 800, but not those ones below, because most of them are already situated and they're already used by the machine for something else. So we shall use port 222 for now, or 2222, and then we come over here and we say server socket object. From our server socket object, now we're going to initiate it, is equals to a new server socket, which is going to take in its method, it's going to take in an argument for our port, and this is step 1. As you can see from the presentation I showed you, that step 1 is to create a server socket object. So let's go back here. After doing that, we need to catch to handle the error associated with it. And we need to print out a message that we can't attach ourselves to that port, just in case of that error. Just I couldn't connect. So after creating our server socket object, now we need it. We shall come here and initiate, or we define another method that is going to handle most of the client's input, and that's going to handle most of the client stuff. So we shall call this handle client, or you can call it anything you want as long as it's related to the topic. And then before we put anything there, I would like to first complete everything with the main method. So we put this in we're going to put it in a loop, like an infinite loop, because we want the port the server to always be running, and whenever a person tries to connect on it, it's always active. So we shall whenever a client tries to connect to it, it will always be active. So we shall put this in an infinite loop, which will call the method handle client, and it will always be true unless otherwise when we close it from the client side. So we come here, and now we are about to go to step number 2, putting the server into awaiting mode. And for this we shall need to try. So we are going to, the reason we're putting it in try, because the methods we are going to use are going to also be throwing a couple of compile time exceptions, or should we call them errors, and we need to handle them. So we shall set our link. The link, this is already, we know it's a socket object, and we shall get this socket object and institute it to a server socket object still, but we shall set this to accept. What this does, it puts our server object into awaiting mode, that it's waiting for a connection to the other port we already set up, the port 2222. This is step number 2. Then we need to go to step number 3, setting up the input output streams. As you can see from the diagram, the presentation. So step number 3, set up input and output streams. So we say scanner. We use a scanner because of course it's input from another machine. Say new scanner. So we're going to set this to, let me see, let's delete this. So we shall use the link to get input streams. Okay, and this is our step number 3. And to access the output streams, you're going to use a print writer. I should call this output. New print writer. Say link dot get output stream. So sometimes you want to set it to auto flashing, so we set auto flashing to true. And this is step number 3 still. So we need to get the message. And this message is usually accessed from the so here we're going to have to put like the sending and receiving of messages. We want it to be in a loop so that we continue receiving and sending at the same time without going through the other steps over and over again. So say while the message got from the other machine is not, we use the exclamation mark to say not, is not equals to, because yeah, to. Let's say we don't want a person to type exit with a hyphen. So if a person types exit with a hyphen, the server will stop receiving messages and sending, and it will close automatically. Yeah. So while that's not it, we say system, yeah, system.out print line message received. I like to put this in those things here. Yeah, message received. Full stop. We want to take account of the number of messages we are receiving, because this is, in case it goes on. This is our step number 4. Yeah, sending and receiving, which actually begins from here, the fact that we receive a message. So this is also step number 4. So once the other person, since this is okay, an echo server, it's supposed to echo back the message. So on the other side, I'm going to say, where is the output? Yeah, output. Since we already have the output streams, output.print line, this will be printed on the client side. Message, the message received. Message number. So this one, since the num message is counting, it will say, oh, the message is number plus, we can give it some spaces here, plus the message itself, the message received from the machine, the message it sent. Then it shows the count, because it is an echo server, it's supposed to echo back what you sent, but this time it will echo it back with a count to show you, yes, this is the message you have sent, but this is the message according to, okay, this is the number of messages you have sent. You send message 1, it shows message 1. You send message 2, it shows message 2, until even message 100. So step number, this is still step number for sending and receiving, because it's a communication. After that communication, what would we do next? That communication, I think after that communication we shall, we continue with what? continue with, of course, getting user input, because this is going to be the loop. The other time it was the opening thing. Actually, let me leave it there. This time it was the opening, but now in the loop we have to continue. Receiving messages. So yeah, this is all step number 4. I need to put step 4 there. Now on the closure, it will give us a count. We need to get a count, but this will all be displayed on the client side. So messages, now messages first, better. So let's say in case it was 100 messages plus received. So it gives you at the end of it, or it will also show you the number of messages received. Oh, we have forgot to handle this exception. Sorry, it's an IO exception. And here, instead of just printing something, how to use this print stack trace. Yeah, better. So we have finished step number 4. We are coming up to our final step, which is closing the connection. Since our communication is done, we need now to close it. We put this in a finally close, and we try. We are trying because, of course, if you try to close the connection and it refuses, it will bring some compile time error due to something. And I forgot to put S on these things here. Yeah, better. So we say closing connection. For that, I like to put my own designs there. So closing connection. Yeah, better. This is our step 5. And actually, to close the collection is very simple. We use the object, the link object, the socket object, and we use its method close. So in case it refuses, we catch, and it causes an error, we catch that error, and we handle it. So we shall tell the other guy, no, something's wrong during the termination. Sorry. Say error occurred during termination, or during closure time, whatever, during detachment, whatever you decide. Step number 5. So since it has refused to close through the socket object, we can force close it using the system. That's this status. We give it a status of 1. So let's test and see if it is active before we create the client. So no errors, is showing opening port. So next step is to create the client that is going to communicate with this. And no, it's not going to be a folder.